Welcome to the webinar, The Crucial Role of Preventive Maintenance in Your Food Safety Program. Before we get started, just a few logistic notes. So everyone, it's going to be in listen-only mode. We will have a Q&A session for 15 minutes or so at the end of the webinar. If you have any questions, put them in the question box as they come up, and we will answer them at the end. If we don't get through all the questions, I will follow up with you after the webinar to get those answers for you. And this webinar is will be getting you the recording tomorrow. Again, welcome. My name is Radoika Britsky, and I'll be your speaker today. I have been in quality and food safety professional for over 20 years. I'm currently the SCS Director of Food Safety Training. I worked 18 years in the food manufacturing and have been training other professionals in the last 5 years. Today, I will be talking about the preventive maintenance and how this preventive maintenance program can influence food safety at your facility. Before we get started, let me give you a little bit background of SCS. SCS was funded in 1984, and we are an international leader in third-party food safety, environmental, and sustainability certification, as well as standards development. We specialize in auditing, certification, verification, training, life cycle assessment, and strategic consulting. We actually have over 24,000 clients. We have over 38 years of experience in the field, and we provide more than 30,000 certifications, and we have auditors in all major markets globally. These are some of the examples of services offered for the food and agricultural divisions. So we have food safety training, food safety consulting, responsible sourcing, advisory and verification, and carbon services. Some of our food safety audit examples as well are showing in this slide. And we do GFSI certifications as well as HACCP and harmonized GAP. Food labeling services are also offered for non-GMO project verification, USDA organic, among others, and sustainable agriculture services such as Fair Trade, Rainforest Alliance, and others. So preventive maintenance program. The development and implementation of a preventive maintenance program is required from businesses in the food supply chain to meet regulatory and certification requirements. When referring to a preventive maintenance program, the first thing that comes to mind is typically equipment. However, there is a require, not only by regulations, but also by certification schemes, that a preventive maintenance program is also applied to buildings and grounds. So let's look at these requirements in the US and GFSI certifications. So under the US regulations, 21 CFR 11720 talks about plants and grounds. So under this rule, the following is required: maintaining roads, yards, and parking lots. In the section 4 of this particular area of the regulation, it states that these roads, yards, and parking lots need to be constructed in such a manner that it is well maintained. At the same time, it also talks about the buildings that must be constructed as well, where floors, walls, and ceilings might be adequately cleaned and kept clean and kept in good repair, that drip or condensate from fixtures, ducts, and pipes do not contaminate food, food contact surfaces, or food packaging materials. In section 21 CFR 11735, that talks about sanitary operations, on subpart A, it talks about general maintenance. In general, this requirement says that building fixtures and other physical facilities of the plant must be kept in adequate repair to prevent food from becoming adulterated. Under this rule as well, under section 21 CFR 11740, that talks specifically about equipment and utensils, the following is required. All plant equipment and utensils used in manufacturing, processing, packaging, and holding food must be adequately maintained to protect against allergen, cross-contact, and contamination. Food contact surfaces must be maintained to protect food from allergen cross-contact and from being contaminated by any source, including unlawful indirect food additives. And it also requires that seams of food contact surfaces must be smoothly bonded or maintained so as to minimize accumulation of food particles, dirt, and organic matter, and thus minimize the opportunity for growth of microorganisms and allergen cross-contact. So what about GFSI? GFSI, each standard has requirements also regarding equipment and buildings. I'm going to just mention few, but if you are familiar with GFSI, GFSI has 9 approved or recognized schemes under this organization. And so I'm just going to touch bases on 3 of them just to give you an idea on how GFSI has established or requires a preventive maintenance program. So BRC actually requires that the site shall establish and maintain a maintenance programs for equipment and buildings. At the same time, they also state that an effective maintenance program shall be in operation for plant and equipment. Under SQF, you'll find a requirement that says that the methods and responsibilities for maintenance and repair of plant equipment and buildings shall be documented. For Global GAP, you will have 2 sections for this requirement. In one, it says the plant shall also assess the need for the maintenance of irrigation equipment in specific, and also that the producer shall take active measures to avoid the risk of pesticide drift and others by doing a maintenance of spray equipment. So why do we really need a preventive maintenance program? Well, one of the first things that we need to, for which we need to have a preventive maintenance program is to ensure food safety of products. So basically to control foreign matter in a way that we know that well-maintained equipment and buildings do not pose a risk of foreign material becoming loose and ending on the food that is being harvested or processed. In addition, well-repaired buildings do not allow for pests or gain access to facilities. Compliance with regulatory requirements will be another reason as to why we need this kind of program. Compliance with certification requirements, as we just saw under GFSI. Maybe compliance with customer requirements. Customers, sometimes they have their own requirements in order to approve you as a supplier. And also for running efficiencies. Although this is not related to food safety, you want to have a well-equipped, maintained equipment, so your running efficiencies are good. Okay. So what is it required for an effective preventive maintenance program? An effective preventive maintenance program has the following components. The first thing is management commitment. Then you're going to do a risk assessment into which your accurate inventory of equipment and parts is going to be included. At the same time, you need to provide or assess risk for building and facilities. Then you're going to create a preventive maintenance schedule, your procedures, your training and employees, develop employee skills, and temporary repairs program and accurate record keeping. First thing we're going to talk about is management commitment. So management must provide the resources for an effective maintenance program. Financial and human resources are required to develop, implement, and sustain an effective preventive maintenance program. If management is not committed to provide the needed resources, then the preventive maintenance program will fail. Each equipment has its unique contribution to the production and will pose different kind of hazards based on type, usage, and maintenance. Therefore, you need to perform a risk assessment of the equipment. You may want to prioritize the equipment that has direct impact on food safety and the ones that are more crucial for your food production. Equipment that is related to process identified to control food safety hazards are highest in risk to impact food safety than those that are not designed for that purpose. In addition, equipment that has parts that are exposed to production lines, such as scales, balances that are used to measure the portions of food that go into a bag in a dry foods company, for example, will have higher risk to contribute to physical hazards than those that are enclosed, like mixing tanks, filling equipment, etc. It is important that the equipment's name, the manufacturer name, the serial number, and the location in the processing area are noted in the inventory. This information also is needed for parts that are key for replacement during a planned or unplanned maintenance event. This information can be placed in the master schedule once it is completed. I'm going to emphasize these, buy the recommended parts by the manufacturer. I had a facility where the run seats for some valves at a pasteurizer were bought because they were cheaper. It turned out that the seats did not last the recommended preventive maintenance schedule to replace them. When they broke, the valves which control the passage of the product through the holding tubes will not open completely. So product that needed a longer treatment was getting the shorter treatment or a mix of both. These led to a major product withdrawal due to spoilage. We were not meeting shelf life. The reason why this resulted into a major food recall or did not resulted into a food major recall was because the temperature and times provided were above the critical limit recommended in the validation study for the pathogens of concern. So we were lucky. However, before we reinitiated production for the product in question, we had to stop production for several months until the root cause was found. This resulted in a loss of several millions of dollars for the company. Again, I'm going to emphasize these because these might be overseen, but buy the recommended parts by the manufacturer. And I know sometimes we get restricted with budget, which is part of the financial commitments that management should have for the facility, but it can cost you a lot more in the long run. Risk assessment of buildings. So as we mentioned, buildings, roads, grounds, and parking lots also need to be maintained as they can also contribute to the conditions that risk for food safety. Regular inspections of the building and training of employees to report any areas of the building that need repair is important. This is a more reactive approach. However, all the aforementioned regulations and programs require a preventive approach. So how can we do that for the buildings? Analyze the data generated through the GMP inspections of the building, roads, grounds, and parking lots. This data review might show you trends to allow you to predict when a door, a road, grounds, or parking lots might need to be repaired before they get broken. Management commitment to provide financial support resources is also important since most of the buildings and its surroundings repairs are not cheap, but are as important as the equipment in the processing of products. A preventive maintenance schedule needs to be developed. So most equipment will come with manufacturer's recommendation on how to maintain the equipment. Follow the recommendations provided by the manufacturer. The schedule is often broken down into daily, monthly, and annual categories. So collect this information the best you can and organize it in a master schedule that allows you to keep track of all these important maintenance dates at once. At the same time, consider how this maintenance will fit best into your operational schedule. Can you shut down production early one day to take care of the maintenance at once? Or is it better to work on them on a rotation basis? I have had worked at manufacturing facilities that have planned PM days for each line, and any identified building or grounds maintenance needed were feed as they were reported or scheduled. I have worked in other manufacturing facilities that had a list of tasks that they needed to be performed at a particular month, and the maintenance personnel will work with the production schedule to fit that task on a weekly basis. It is important that the entire manufacturing facility team is involved in the communication loop for the equipment and building. PMs needed. So scheduling is following and high-risk equipment is not oversight. Again, management commitment is important for this task. Unexpected fails might happen that can deviate the schedule a little. However, emphasis must be made to reschedule the tasks needed, if possible, within the same week, so there is no risk for oversight or on the equipment. I should add here that if the delay is in a preventive maintenance for an equipment that is actually related to the monitoring or performance of a food safety, to control a food safety risk, then that need to be given sense of urgency to get it back on a schedule as soon as possible. For a preventive maintenance program to be effective, you must have processes and procedures in place. You must start with writing what is the procedure that must be followed to provide preventive maintenance to the equipment, the building, and surroundings. So this is pretty much a general program that you're going to develop. Now, when you develop procedures, you can include work order processes, a scheduling process, the identification of tasks to perform internally or externally. Sometimes you need to hire contractors to do the preventive maintenance, and who is responsible for the tasks and the management of the program, and how the program is verified to ensure that it is being followed as written. In addition, there should be written procedures on tool management and how the equipment will be turned into production once the preventive maintenance or emergency repair is done. When performing preventive maintenance on buildings and surroundings, special care must be taken to separate the areas being maintained from the production areas to avoid any cross-contamination resulting from the PM activities. Each piece of equipment should have an SOP in how to be maintained or repaired when needed. I also should add here that in your procedures, you need to include a portion that explains on how tools are managed. So the preventive maintenance team or the maintenance team, when they work on a repair for equipment, their tools can move around the facility. And unless you have a tool control on how these tools pass from one room to another, you are exposing yourself or increasing your risk of having either cross-contact or cross-contamination hazards or issues. So if you cannot dedicate tools to specific rooms or you need to use the tools as you move around the facility or you are maintaining equipment, then you really need to stay clearly on how these tools are being managed. Do you have any cleaning protocols that you apply for your tools? Is that feasible, right? Tools, materials might not be compatible with all the chemicals that you use at the facility and actually can lead to corrosion of the tools. So that actually will put you at risk as well. So again, I refer to all my preventive maintenance and maintenance experts out there to design a program for tool management so that tools do not become a source of cross-contamination or cross-contact for the facility. Training is essential, so maintenance personnel must be competent to perform the tasks that are assigned. They must be trained in the general procedure and procedures that are relevant to the equipment that they are assigned to. In addition, equipment and building surrounding repairs should be assigned according to the skills that the employees have. You can't assign a repair that requires welding if the employee has not received the proper training on welding for food manufacturing facilities, for example. Actually, welding for food manufacturing facilities is a specific skill. Not everyone has them. And as I mentioned earlier, in the regulation states that welds that are performed on food equipment needs to have a smooth finish, so there is not risk for material to be deposited in those seams that has been welded and therefore represent either a cross-contamination or cross-contact risk. You should not be assigning jobs that need the manufacturer's technical expertise to internal employees either, unless they're actually trained and actually taught by the manufacturer technical expertise, and they have some sort of sign off saying that your employee now has been trained accordingly to their standards and are able to perform those repairs or maintenance. So it is important that personnel performing any maintenance task is competent on the task of being performed. Temporary repairs. So we use those sometimes at the facilities just because either there is no equipment or there is no parts available at the time. And there is nowhere in any of the literature that I have read that says you cannot do temporary repairs. However, there is actually a caution tape around that, into which it says that temporary repairs basically cannot become permanent repairs. Okay. Again, occasionally you'll need to address small issues with your building or equipment with a temporary or short-term fixes. However, you should have the equipment and personnel and staff to handle this smoothly, even with maintenance schedule in place, and fix that permanently as required as soon as possible, okay, within reasonable time. So as with most responsibilities in the food industry, your equipment maintenance should be documented. If your facility is inspected for food safety standards, you'll need this evidence on standby. And if something goes wrong with one of your machines, your maintenance records might be able to help you pinpoint what went wrong and when. So that's part of the root cause analysis. And record keeping is important also when you either have regulatory inspections or when you have third-party audits, because they show evidence that you have maintained a schedule, that the preventive maintenance on your equipment and the buildings and the surroundings have been done per the schedule. And it shows, again, management commitment. So how does an effective preventive maintenance program can affect food safety? So lack of building maintenance can affect the food safety of the products as follows. So in terms of food defense, some of the mechanisms to defend the product from an intentional adulteration due to an external attack are closely attached to the building barriers functioning properly. Here are some examples of lack of building repairs that might lead to a food defense incident. Disruptions on the fence or walls surrounding the facility, doors not self-closing, batch mechanisms to access the building unrestricted areas are not working, or chemical storage areas not being protected. So in terms of water accumulation, holes in the ground and poor drainage can lead to water accumulation. This will attract pests who need water for their survival, and also accumulated water is part of insects' reproductive system or cycle. Building holes, holes in the building's structure are easy access points for pests. In addition, roof leaks can lead to the introduction of pathogens into the environment of the plant. We also know that lack of building repairs can lead to chipping paint or pieces of the building falling into areas where ingredients or finished good is being stored or processed. So these pose a risk for physical hazards in the food. In terms of equipment, lack of equipment maintenance can affect the food safety of the products as well. When you don't have good equipment maintenance, you increase the risk to introduce biological hazards. You might have instruments that are essential to measure a critical limit designed to control or minimize the pathogen or biological hazard to an acceptable level. Therefore, this must be maintained in good repair and always calibrated. Increased risk to introduce chemical hazards. So, for example, over-lubricating due to lack of standard operating procedures and trained skilled personnel might also represent a risk for chemical hazards introduction. You also can increase the risk to introduce physical hazards, for example, when equipment parts can detach and end in the food. Some of the common audit findings related to preventive maintenance are lack of program, process, or procedures. Program is not followed as written, so you either have a schedule that looks good in paper, but it's not really being followed. There is a lot of delays on the schedule, or people don't get to perform the preventive maintenance as it is written on the schedule. Sometimes you have lack of a schedule. You have the program, but you really have not scheduled. Preventive maintenance schedule is not being followed, as I mentioned earlier, lack of records, lack of personal training, lack of personal skills, and lack of financial resources as well. I should say that financial resources sometimes are reflected on the building itself and the roads, because these tend to be capital projects, you know, to pave the road or to patch the road could be expensive. So you can find common findings on that under the preventive maintenance program. Now let's just talk really about real examples. So I don't know if any of you is familiar with Peanut Corporation of America. Peanut Corporation of America was a peanut processing business with the headquarters in Virginia. And Peanut Corporation of America actually was founded in 1977 and initially run by Hugh Parnell, father of Stuart Parnell, with him and his two other sons. The company was sold in 1994, and in 2000, control of Peanut Corporation of America returned to Stuart Parnell via private sale. Over this history, Peanut Corporation of America came to operate processing facilities in Blakely, Georgia, in Virginia, and Plainview, Texas, providing peanut and peanut butter products primarily to the institutional food market, so school, prisons, and nursing homes, to food manufacturers for use in cookies, snacks, ice cream, and dog treats, and other low-end markets. In late 2008 and early 2009, as a result of a salmonella contamination event, 9 people died and at least 714 people fell ill, and all from after eating products containing contaminated peanuts. This contamination triggered the most extensive food recalls in US history up to that time, involving 46 states, more than 360 companies, and more than 3,900 different products manufactured using PCA ingredients. The contamination and recall had immediate major ramifications for the market on these products. And on February 13, 2009, Peanut Corporation of America ceased all manufacturing and business operations and filed for Chapter 7 bankruptcy liquidation. As of February 2009, a federal criminal investigation was continuing, and at least a dozen civil lawsuits have been filed. In September 2015, Stuart Parnell was sentenced to 28 years in federal prison for his role in the nationwide outbreak, and Stuart's brother, Michael Parnell, was sentenced to 20 years in prison. And I'm going to say that the QA manager that was at the time in that company was also sentenced 15 years in prison as a result of this outbreak and the involvement of this person in the actual issues. Now, when you look at the 483s issued by the Georgia and the Texas facility, there are several failures that are noted. One of them, or some of them, are lack of sanitary operations, lack of sanitation controls, lack of material controls, lack of building maintenance, lack of pest control, and lack of validation of peanut roasting process. As you can see, and out of this list, only one was actually related to the HACCP plan. And that was only for one of the facilities HACCP plan where the roasted process was not validated for the peanuts. All others are related to GMPs, and one of the findings, as she said, it's related directly to the building maintenance. So I'm hoping that this list gives you an idea that your foundational programs, such as preventive maintenance, actually play a vital role in your food safety. That's the reason why prerequisite programs are called foundational programs, and they should be written before you actually develop a hazard plan or a food safety plan. So let's take a look at the FDA 483 for the Georgia manufacturing facility. So if you don't know, 483s are formal noted observations that are provided during an FDA inspection if nonconformances against the regulations are found. These documents are made public once the inspection is completed. So if you go to the FDA and you're more curious about what else they found, because I'm going to name here only those findings related to preventive maintenance, I recommend you that you go to the FDA website and type 483 Penal Corporation of America, and you can get actually a PDF copy of that 483 if you're interested to learn a little bit more. So for the Georgia manufacturing facility, there were a total of 10 observations, of which 3 were maintenance issues. They found water stains observed running down from the unit cooling fans in the cooler. And on January 10, 2009, pallets of finished product were stored directly beneath this unit. That the plant is not constructed in such manner to keep ceilings in good repair. Specifically on January 10, 2009, there were open gaps observed as large as ½ inch to 2.5 feet at the air conditioning intakes located in the roof of the firm. Water stains were also observed on the ceiling around the air conditioning intakes, and additionally, there were water stains and streaks located on the edges of the skylights where the rainwater has been leaking into the firm. All of these openings were located in the production and packaging rooms. Totes of finished roasted product and roasted peanuts packaging line are located directly underneath these areas. The third finding was effective measures are not being taken to protect against the contamination of food on the premises by pests. The bumper pads used for sealing the trailers against the bay doors were inadequate in that openings of 6 inches or more were observed along the sides and tops of the trailers. These trailers containing raw or roasted products in totes can be left backed up to the bay doors for 5 or 7 days, allowing these openings to exist. For the Texas manufacturing facility, out of total 8 observations, 2 of them were related to maintenance. The first one was failure to maintain buildings and physical facilities in repair sufficient to prevent food from becoming adulterated. Specifically, they found roof leaks where rainwater were observed dripping into the plant's peanut processing areas were observed at the following locations. In the pre-clean area above the space between the gravity shaker and raw peanut tote dump station, roof leaking at overhead hanging doorway leading to the pre-clean area, roof leaking in the hallway diagonal to the northeast of the doorway leading to the oil roasting and granulation process areas, roof leaking in work in progress or in process area and pooling on the floor between organic and oil stock storage areas, roof leaking in work in progress area and pooling on the floor below between storage areas, and roof leaking in work in process areas and pooling on the floor below between storage areas identified in different parts of the facility, a potential roof leak in northeast corner and northmost room in the kitchen or lab room and puddle observed on the floor room. Paint chipping and peeling observed over dumping equipment located at northwest corner of the receiving pre-cleaning area. And secondly, devices and fixtures are not designed and constructed to protect against recontamination of clean, sanitized hands, specifically the hot water, food operated valve, and the hand washing sink at the primary entrance of the processing area was not shutting off after use, and you needed to jiggle the foot pedal or pull upward. So it was not maintained. So I just want to be sure that you remember that preventive maintenance is a prerequisite program and prerequisite programs are the foundation of food safety, as I mentioned earlier. You should not have a HACCP or food safety plan without actually writing all these prerequisite programs and ensuring that they're functional, because if they fail, you can have a good control. Let's say in this case was the roasting of the peanuts, that is validated and might be functional, but then you're increasing the risk of the introduction of biological hazards either through pest activity or environmental contamination, and therefore your method of control is not going to be effective. So this concludes the webinar. I'm going to actually open the question to see if there's any questions regarding the webinar itself. I don't see any questions that has been provided. So because there are no questions, I'm going to assume that you don't need any additional information. If you do, again, this webinar is going to be actually there is a question. Do FDA or any GFSI schemes require a computer-based preventive maintenance program? No, they don't require a computer-based. That's going to be up to you on how you establish your preventive maintenance. I have worked at facilities or most of the facilities that I have worked at, they choose to have a software because it's easier for management. When you have a software and people train on the software facilitates the PM process, and that's why they choose to do that. But no, nowhere in the regulation or the GFSI scheme requirements, it says specifically that your program has to be automated. Does SCS recommend any computer-based PM programs? No, we don't recommend any computer-based programs. There are several out there. I will just rely on the expertise of your maintenance manager or any other colleagues that you may have, or people that have experience with software for these kind of recommendations. How much important PM for warehouse storage and packing goods? Well, it's the same as as important as production. I can tell you that again, if you don't have a good preventive maintenance program for your storage facilities, even though the product is already produced, if you have, like, let's say, gaps in your building and you have rodent activity as a result, then you're increasing the risk of biological hazards into that product, even if they are boxed. Okay, I mean, you'll have rodents like urinating or defecating, you know, on top of boxes. You might have rodent activity that is trying to actually get into the boxes because they see the product in the boxes to be a source of food, and that is not good for food safety. At the same time, if you don't have proper building maintenance, you might be increasing the risk for foreign contamination to come into contact with the box product, which if it's shipped to one of your clients, then now you have issues at that end, not only from your customer service and complaint process, but also if they decide to accept the product and open, when they open the box, they can have that foreign material somehow contaminating again the actual product that was packed. How should you address missed PMs? Well, missed PMs should be addressed to be completed as soon as possible. Now, what I just said is, in the real world, right? You have a production, you're running. If you're a small facility, I have worked for facilities where product was made to order, meaning that basically what you were making that week was out the door. So for us to have a breakdown in the process meant that everything else was backed up, right? So if you had an equipment malfunction and it needed to be repaired, you repair it right away as soon as possible. So preventive maintenance in that particular facility was really tricky. but it was managed to the point to where we abide to the preventive maintenance to a 98% or above completion. And so we establish a KPI, key process indicator, or some people call it key business indicator. That KPI was reviewed on a monthly basis on management review, and importance was given to that number. And everybody in operations was held accountable for the PM completion rate. So that's how I would manage, backup schedule. Now, if you have the occasional breakdown on the PM and you couldn't get to it, if it happens twice a year, yeah, you need to put corrective actions in place because it is needed that you abide to that. But if you have consistent breakdowns because people are not giving the importance to the program, that's when these facilities get into trouble, as you saw with Peanut Corporation of America. Will there be any notes for this webinar? There is a lot of valuable information, but the speed of the presentation has been hard to take notes. I spoke as slow as possible. The deck will be available to you. I'm not sure about notes, but if you do have any questions or need additional information, you can reach out to the people here on the screen, or reach out to me at rbaryczki, so RBARYCKI at scsconsultingservices.com. I cannot consult, but I can answer a few questions if you have any small questions about it. Can you relate any further stories about maintenance issues that contributed to food safety problems? Maybe someone left a maintenance tool in a piece of equipment, or the toilets were not repaired, so flooded into the production area. Do you have any fun stories to relate? Well, the fun story that I related earlier was actually the one that happened to me with the valves. Another one that was related to the same market action that I have. So once we detected the valve issue, we thought, okay, we found the root cause, we're good to go. 6 months later, we were in the same situation. We had, this was a low acidity product that was blowing up in the market. Like, it wouldn't last. It was designed to last 90 days in the market. It was not lasting even 2 weeks after it left our facility. So we had to go back to the drawing board. So we said, okay, the seat valves are already completed, and we know that's not the root cause because we actually follow through with the corrective action and everything, and that was verified and it's working fine. So what's happening? So we went back, and it turns out that this product was using as an ingredient reverse osmosis treated water. When we looked into the reverse osmosis system, that we actually shut down the plant and dismantled the RO water system, we had a lot of bad findings. We had to redesign the entire system, and we had to learn a lot about RO water, preventive maintenance of RO water, and sanitation of RO water membranes. It was a learning curve for me, for the preventive maintenance manager at the time, and eventually we hired a sanitation manager that was responsible for the overall program for the RO water, who was responsible for the cleaning cycles and all that stuff. So that was part of the learning process for us as well. Now, you might be asking, well, what led to that two major breakdowns at that facility? Is it because people didn't care? Is it because management, at the time, we had a breakdown in management. That facility in 1 year had 5 different plant managers coming through. So we couldn't hold like the leadership, the main leader at the facility, for one reason or another. The facility was challenging. And then the senior management at the facility was designed, because we were a high-risk facility for that particular corporation that we were working for, was designed to have managers in key positions, up to 11 management seats. That's how big our management team was. Well, for that particular year, we were reduced to 5 people. So again, we all had the commitment to do our best, but and I'm not making excuses, but the lack of management attention, because we were wearing too many hats, that's what led to actual issues at that particular facility. I have not had toilets overflowing on me, but I did have a particular facility. I worked for a carbonated soft drink facility that was running. It was a bottling company that was running on a 40 plus years old building. And if you know the construction back in the day, your drains were not made sanitary enough back in the day to withstand the amount of acid that this kind of operations run into. So if you had any spill that we had at that facility resulted in eventual corrosion of your drains. And that eventual corrosion of your drains meant like a lot of drain work that needed to be redone. So that was a challenge for that particular facility, because we had to tackle that as it presented. It couldn't be as preventive as we wanted to. So those are the challenges that I particularly have faced in my career regarding preventive maintenance. I hope that answers your question. I don't see any other questions. So I hope this webinar was very informational for you. And as I mentioned, you're gonna get the recording of the webinar tomorrow, and then shortly after that, it will be available for our website, on our website on the resources. So if you wanna refer anyone at your facilities to listen to it, it will be available for them as well. Was I ever involved in the maintenance field? No, I was actually a QA manager. So as a QA manager, you're a jack of all trades, basically. I was very involved in maintenance programs. At that facility that we're speaking to about the seat valves and whatnot, shortly after, so I was in that facility for 11 years. And thank you, Frank, for the kudos of the well done. That facility that I was at, I was there for 11 years. And I had fun experiences, not only related to maintenance, but a lot of things. One of them was actual allergen recall that I was involved in too, story for another day. But in 2000, it was a juice processing facility, or beverage processing facility, I should say. In 2006 or 7, there was a recall for carrot juice from a competitor of ours. But because we were pressing carrot juice, we were affected by the consequences of the recall, because it changed the industry. You had to reinvent how you process carrot juice, basically. So the FDA wrote a guidance, if you're interested to know. And you can type on the FDA carrot juice guidance, and it will pop for you. But they basically gave the industry 2 options. You either acidified and pasteurized your juice under regular pasteurization temperatures, or you had to UHT, like ultra high temperatures, almost HTST, like high short time temperatures of above 200 degrees Fahrenheit, to basically make a sterile product. And this was to actually deal with Clostridium botulinum spores. And so we chose the heating of the product, and that meant that we had to design a pasteurizer specific for carrot juice processing. So I was involved throughout that process with engineering. I was the point of contact in terms of quality through the engineering process, the qualification of the pasteurizer. I was responsible for the validation of the whole tubes, and we did something that is done in the dairy industry. It's called the SOAP test, which is done by the Department of Health to actually verify the holding tube and temperatures, or the holding tube length, actually, for the pasteurizers in the dairy industry. They go quarterly to do that. So I adopted that method for that facility, which was adopted corporation-wide later on. And so I had a lot of engineering exposure, if you will. So again, I was never in the preventive maintenance field, but I had a lot of exposure. And I was involved with the sanitation manager, who is a good colleague of mine and friend, who is a certified sanitarian in a lot of these troubleshooting. So I learned a lot from him as well. Thank you. Thank you, Aracelis. So, okay, well, I'm gonna close the, you're welcome, Pedro, or David, David Pedrosa. So I'm gonna close the webinar now, and I wish you guys a good day, and I hope, again, this was informational, and I guess I'll see you in the next one. Have a great day.